Welcome everyone to today's CSIA Wednesday webinar series. My name is Colin Hammond and I will be your host today. For those of you who are unfamiliar with CSIA, we are a global nonprofit professional association with over 500 member companies in 40 countries. Our goal is to advance the practice of control system integration to benefit our members and their clients. Our vision is to ensure that manufacturing and process industries everywhere have access to low risk, safe, and successful application of automation technology. CSIA membership offers members access to resources needed to attain and exceed business goals. To highlight just a few of our many member benefits, the CSIA Best Practices Manual guides control system integration companies in the setup and running of a solid company. CSIA's Business Insurance Program offers members an excellent insurance program for business owners, subcontractors, and more. The program includes members from all over the world enjoying the peace of mind that comes with CSIA insurance. Clients in all industries are now seeking integrators with a CSIA certification alongside ISO. They recognize CSIA certified integrators' commitment to industry standards and business acumen. As a result, being certified can shorten the sales cycle. CSIA Industrial Automation Exchange is the premier automation guide featuring system integrators and suppliers who provide industrial, manufacturing, and process automation solutions. For integrators and suppliers, it's a place to market their expertise. Clients will find white papers, case studies, capabilities, contact information, and engage in conversation directly with CSIA members. And be sure to follow CSIA's online events calendars for all upcoming webinars. You won't want to miss these opportunities to learn from the comfort of your own office or home. And this includes our new upcoming virtual webinars. And for more information about CSIA, please visit our website or contact us at info@staff.controlsys.org or 847-686-2245. And at this time, I would like to introduce and pass it over to our presenter, Blair Sooley. Welcome, Blair.
How you doing?
Wonderful, Blair. Yes, sir.
All right. So you wanted me to go ahead there, Colin?
Yeah, I will go ahead and stop.
All right. Well, thank you all for the opportunity to discuss this system with you here. I'm going to cover the City of Houston project. It's called the NEWPP. Just give you a little bit of background about myself. I'm with VTScada. We're a global provider of software for use in the industrial control and monitoring world. I've been with these guys for about 18 years now. So my background is in electrical engineering, in control systems, and I've done a fair bit of involvement with the industrial side. So talking up in mining, talking the big three, working in Detroit for a while, down in California, now over in Texas. And I'm originally from a place called Newfoundland. So any Canadians out there, how do you do? So with that said, I'm just going to switch over to my screen and we'll start showing you this project. Now, can you see that, Colin?
Yes, you are good to go.
Okay, so I'm going to shut off my webcam while I'm at it there. I think I should be able to do that. Stop video. Okay. All right, so if you look at the label on this thing, collaborative multi-user integration platform, blah, blah, blah. I tried to use every character I think I could possibly get, and I think I exceeded them. So this is probably the longest named presentation you'll watch in a long time. What I'm going to cover here today is a methodology that we have adopted over at the City of Houston for rollout of a major project. It's in fact an extremely large project in the nature of about 1.4 billion. for working efficiently, working effectively, and minimizing the human error by automating manual tasks and then reducing risks. So we're trying to work in a shared online real-time environment to identify problems as early as they possibly can within the project so that we can address them. This is a long-term project. It's going to take a total of up to 6 years to finish the entire rollout. So I'll go into some of the details of it. I'm going to cover the project problem first. So the key here is addressing the Houston-Galveston regional subsistence problem. So what we have is a problem that's actually started in the mid-1800s, where there's an extraction of oil. This is the Houston area. So we started extracting oil from the ground, and then as the area grew, they started extracting a lot of water from the ground. The problem with doing that is that all of this liquid is maintained in silt-based underwater reservoirs. And as you extract the water or the oil from there, the silt begins to collapse, no longer holds its formation, and the ground slowly starts to sink. So this is a map contoured for defining the 1-foot intervals of subsidence that you would get across in the Houston-Galveston area. And you see certain areas here. You've got an area of 10 feet drop here, 9 and 8 feet. This is the worst of all areas. And down around the Galveston area and below, you get down through 4, 5, and 6. As you probably know, this is also a heavy area for flood. So we have to really consider the problems that would accumulate due to subsidence, and then combined with the additional hurricanes and water that we get here. So it is the sinking of the ground, and the resulting problems are essentially that you cannot store as much in an aquifer. So therefore, you've now reduced your ability for water storage. You do have submerged land. You do have all kinds of problems with your water system. And in particular, a lot of infrastructure around the area starts to either collapse or be damaged as the ground moves. And of course, everything is more potentially hit by floods. So this is an example here, Crystal Bay, 1944. You'll see there, this area in particular called Brownwood was hit particularly bad in this bay. If you look at it in the 1978 time frame, you'll see that this area is completely gone underwater. And it's really relevant when you get a good close picture of it. Here you can see that this area has dropped over 3 feet. This was a well field back in the late 1800s. So you've got significant damage to this area. It's essentially just been abandoned, and they leave it there as an example. So the Houston solution to this was to address twofold. One, the subsidence issue, but one, a growth of the general area, the population. The area population has changed from in the mid 2 millions all the way up to about 6.6 million today. So we have a massive population growth in the area and all across Texas. Therefore, more water. And this is an area not exactly known for cutting down on water usage, let's say. So I noted here that this is 320 million gallons per day. It's actually 80. I'm going to show you a video now that kind of goes over the project quickly. And while it's going through this 1-minute video, it will give you some understanding of what the project scope is. You see here a large coverage area. You see those house building lots right behind. And this covers a massive area. It's essentially a twin scope. There are 2 trains that are going to be part of this project. One is in phase 1, one is in phase 2. It's going to grow to approximately 400 million gallons of water per day, starting with the existing 80 and expanding into pure surface water usage. Currently, the 80 million gallons is groundwater. As I mentioned, the cost is about 1.4 billion, and the time frame is between 2018, so it's already started, and ending in 2014. One of the big interesting pieces of this is in particular the two extremely large transmission mains that carry the water, and they are essentially a 9-foot diameter main. So that gives you some perspective as to the scope of the project and the sheer magnitude of what needs to be done here to treat that level of water. Okay, so that's the entire project you're looking at there. And if you look at it at the moment, it looks like a lot of mud and a few holding tanks. Okay, so we're going to switch back to the presentation. This just gives some of the information about the parts that are included in there. So the part that we're interested in is the control and plant SCADA architecture. And the area that I'm really interested in particular, or involved in, is the software portion of that, because it's using our VTScada software. So I'm part of the integration oversight team, if you will, assisting the integration team in making sure this thing gets rolled out correctly and assisting them where we need to. We do these kind of oversight plans for everything in oil and gas and renewable energies and large transportation projects and other things that we're involved in as well. Pipelines, we're doing the Alaska pipeline up in Alaska. So this here is an example of the architecture, comes from the spec, and it shows you all of the major areas that have to do with servers, clients, the software portion of the project. And this is the entire network here. Here is the primary server configuration part, or the primary server center. And here you'll notice you have 4 I/O servers, a SCADA server 1 through 4. There are 2 pairs. One pair is on one side of the plant, and the other one is on the other train. All 4 of them are going to be servicing PLCs in real time for this plant. And we've done that because of the CPU usage that's required in order to get, say, 1-second update times on real-time data coming from these plants, coming from the PLCs in the plants. We also have historian servers. We have thin client servers. We have alarm notification that's going to reside on the SCADA server as well. This is the control room section where we have a multi-screens, we have quad screens, we have a monitor wall with 6 screens on it that will be able to be utilized either as individuals or one overall screen that'll show everything. Show just a general overview of the whole plant, for example. These are various engineering and other workstations that are going to be throughout the system. And then we have a DMZ section, which is going to be a lower security section where we're going to be sending data through a data diode shown just outside my box right up here, and feeding a historian that will be utilized elsewhere on the business side for analysis and reporting. We also have a duplication of the data into this side of the existing plant. That's the 80 MGD plant, so that they can have a view on the larger 320 MGD plant when it's done. And then we have control rooms, various control rooms throughout the whole facility, and panel interfaces that are all shown here. So there's about another 18 or 19 that are shown here. It's actually expanded since this graphic has come out, and we have somewhere in the nature of about 20. So we expect that will even grow from there, and they might want additional interfaces as well. The components, I went over most of the components just in that quick description, but we have about 200 PLCs, all using Rockwell Ethernet IP as the protocol. So we're using direct comms to these PLCs. We have a quad redundant load balanced I/O server system, so that at any point one of those servers drops out, the entire load will be redistributed to the other 3 redundant servers, and the same thing, you lose 2 can take over, and you lose 3 and 1 can take over. It's kind of like a jet in that way. We have redundant alarm notification, also utilizing the quad redundant servers. Real-time replication of all historical data. So within a split second, all data is duplicated on 2 servers and backfilled in the event that you lose one. It comes back up. Okay. So let's move from that into the functional requirements set here. And the intent is to have this thing 18.2 standard compliant for alarms, 101 compliant for HMI design. Now, it's worth noting there almost, and you'll see why almost at the when I show some screens of this system. We wanted to have tight compliance to color and layout standards. As we go through, we're going to be throwing out about 160,000 tags, thousands and thousands of sensors, many screens, displays. So having a highly templated design gives us the ability to quickly roll out additional pieces of it. The challenge that we run into here is to create a collaborative SCADA integration environment. The last piece is the interesting part. In particular, it's among friendly competitors. So when we look at our friendly competitors, this is what's called the Houston Waterworks team. These are 4 big names in the Houston area. 3 of them you probably know extremely well, as they are major players in the whole controls industry. Jacobs, obviously, which offices all over the country. CDM Smith, also offices all over the country. And Prime Controls, one of the largest integrators in the country. In this case, they are not providing integration services, but rather panel services. And Embro Engineering, which is a local firm local Texas firm, let's call them. These are some of the responsibilities that Jacobs is doing, in particular the alarms management, network architecture, and then creating displays, templates, and PLC programming. So you'll see a lot of that similarity with CDM Smith, who's also taking the project lead, creating the SCADA standards. And then you have Prime, who's a major supplier of all of the equipment and software components. And then you have Embro Engineering, who's providing some ancillary displays and doing some of the same things. So you have a lot of, it's not duplication of functionality, but they're creating tag templates and widgets to represent the specific data sets that they need in order to make their portion of the system work. And thus the reason for the explicit or the utilization of the SCADA standards and adhesion to them. So how do we get started with this? And we started talking about this and we realized quickly that we would have this kind of a process. Keep in mind, we have licenses that are going out from Prime, who's purchasing them. Then we have standards from CDM, tag templates, alarm widgets, some widget templates, alarm widgets going out there. We have widget templates. We have additional widget templates. And we are just about ready to get started with the development of the plant now that we have these basic sets of functions. It quickly became evident that this methodology was not going to work for such a large-scale project. So what we needed was a system configuration process that made sense. And when we looked at this, a typical simple project, you would end up with a linear type of a configuration. Pretty much everything is known out of the box, and you can start working on a very organized methodology. And as much as you try that with a large scale process, you end up with something like this. You start creating standards and templates and widget templates, and then you modify the standard and modify the tag templates. So these are the modifications that I did not include in the drawing, in the graphic earlier. That was an assumption that everything worked in a linear fashion. This is more reality. And we've known that now since we've been going, is that as much as we try to standardize and create our templates out of the box, we immediately run into problems as things change. They always modify. And the key is making sure that everyone is going to be working together and working on the same set of data. So we needed a flexible, centralized solution to handle the simultaneous modification and expansion, so we didn't have to do everything in linear and therefore slow down the process. Traditional multi-developer environments utilize a version controlling platform, a repository that allows you to check in, check out your data sets. And when you've done that, you do essentially offline configuration or configuration in Teams, and then check in and check out those files. It has a benefit in that it's much simpler to set up, but it does cause problems in lockouts and management, and you're always working on an outdated configuration. The moment you take a configuration away and others make changes to other files, you're working on an outdated configuration that you may need, specifically if you need templates. So you end up with lots of manual intervention, reorganization, resynchronizing, going back to the well, getting new versions. So we realized this was not really going to work. Typical version control systems are not designed for SCADA's continuous change processing. So we created an even bigger thing by, we said, creation of a real-time, online, centralized configuration environment for decentralized offices and friendly competitors, work-at-home people, and everyone else we could possibly jam into that group, every circumstance we ran into. So this has been an ongoing process of figuring out the ways that this will work best. The general requirements for this is that we had to maintain the standards. We had to maintain standard templates and allow them to be both created and modified as we went through. These changes had to be deployed in near real time. So if a change was made by one group, then it would be immediately seen by others who could then utilize it and make their own changes. And we had to share these data with live information so we could do inline testing as much as possible. So rather than linear development, linear testing, everything could be done at the same time, essentially. We didn't want any disruption. This caused a bit of a headache. The test PLCs were located at the partner offices and homes. So if we wanted to have a centralized location, we had to deal with that. File protection had to also be included in this, not only version control, but all changes recorded based on who did them, when and where, and the ability to remove or add in additional specific changes as needed, roll back to known good versions in the event of catastrophic problems, and have duplication of everything for disaster recovery. Here's one of the other problems that we ran into. Geographic distribution of the integration partners. So you see here, Jacobs, major partner, Seattle, Madison, Wisconsin, some other teams as well, CDM Smith, major partners in Tampa, Boca Raton, Houston, Embro Engineers in Houston, and myself in the Houston office here working with these guys, as well as our support offices in Bedford, Nova Scotia, and Ottawa, Ontario. And finally, a wee bit of the Aberdeen VTScada office as well, helping out where we needed. So we had to figure out a way to have everybody be able to access the full set of information in the easiest way that supported the whole process. This is what we came up with. It's introducing the integrated real-time multi-developer whiz-bang environment for configuration of a big system with a whole bunch of different people in different places. What we end up with is the ability for users in various locations, Seattle, Madison, under Jacobs, they could get a copy. What we did was set up a centralized virtual cloud configuration. We used a computer in New York for that. That was owned by Jacobs, and it was managed by the Jacobs IT team. They then loaded the basics of the VTScada product on there, and we took the start of the project and allowed the various groups to commit real-time changes to that so that they were completed on the central virtual cloud configuration system. and accumulated there. But by being connected in real time, we could also allow them to obtain a real-time synchronized copy of the entire system configuration, such that any additional changes they made would automatically be real-time synced back out. The change by CDM would be seen immediately by Jacobs. Now, this had some additional benefits as well, in that the system itself utilizes or maintains a complete configuration control of the system. And therefore, if needed, they could go to the VTScada support team, either offline by providing a complete configuration with the change history, or online by providing remote desktop support. So we didn't actually have to get access to the centralized cloud servers. You then also have Embro. Embro was doing offline control, offline configuration. So their changes were made there and then synchronized back to CDM. Okay. So this is some of the summary of that system. We had a centralized configuration manager. We had online configuration without the SCADA environment requiring a restart. Okay. We have automatic change capture. So every change made by each person on the real-time and, on the online and offline configurations were automatically captured. That information feeds into an integrated version control system that allows both rollback and tests for conflicts upon rolling the pieces together. We have distributed duplicated configurations, so protecting our data. And we do that for two reasons. One, pure protection. A copy of the configuration is available to everyone who's synchronized with it. You can also create a configuration that includes the version control and is sent out to somebody else, say Embro Engineering, in order for them to do offline configuration with a, as best we could do, real-time updated version of the project. And additionally, the support team could have the same set of data so that or same set of configuration and version control information working there. When changes are made, there is a methodology for resynchronization and redistribution of these system changes for both offline and online changes. And finally, we have reassignment of servership to different computers without requiring restarts. This became very important later, and I'll show you that. So the pros to this, it's very simple to set up. It sounds very confusing, but in reality, it's all built into the product, so it's very simple to do all of these things. Automated, requires no manual intervention. So we've eliminated a lot of the administrative work that can be, is essentially wasted time in managing files and making sure everyone adheres to the right processes. We have a change history with every project file, so someone can verify where all the data's come from. Excuse me. It's flexible, it's scalable, and it's fast. But it does require very knowledgeable IT personnel to configure getting everyone connected, specifically when they come from different corporations. So there were some networking challenges in particular. This security requirements and competing partners problem led us to a situation where they wanted centralized configuration synchronization, but without direct access to either the servers or the file repository. So all the work had to be done on the workstations and then automatically synchronized and managed, and files management done by the centralized system. The decision was that only primary partners would get connected network access to the central server network. So that's the reason Embro did not. Major partner in some ways in the integration, but not one of the major two integration partners. There would be no pass-through network connection between partners' development computers. So again, all of the information had to be synchronized to the central, and then redistributed out to each of the development computers, which were in all of these different offices. So that caused us a minor bit of a headache as well. And to do with that graphic that popped up earlier on the lower right-hand corner, this is to do with NATing, or Network Address Translation, on VPN connections, which was a whole new thing to me that I knew nothing about, but thankfully we've got people who do. And what we realized was that as information was being sent from the development computers to the central location, the location or the network address that information was coming from was being modified. And this causes some major confusion to systems that use what's called a push methodology or event-driven, which is what the platform we're using has. Therefore, and when a change is noted, efficiently, it will push that change out to everyone who needs to know about it, rather than using a polling methodology, which is typical of a lot of older SCADA systems. They poll the central for a central server to see if there's any data. Event-driven systems need to therefore have consistent connections, network connections, and knowledgeable, know about the IP addresses of these remote connections so that they can continue to send out the links or the data to these known IP links. So what do? We simply eliminated the NAT, and it made the world turn so much better. All of a sudden, we went from a circle looking like a triangle to all circles look like circles and all triangles look like triangles. So that may sound very simple, but thankfully the Jacobs IT people knew exactly how to do such a thing, and all VPN connections immediately worked, and we ended up with our synchronization working extremely well all of a sudden. But that took about a week of investigation to get there. Change management challenges. We had a couple of these too. We've had this change management capability within the product for a long time, version control and change management, but we had the challenges in that we did not realize that if a set of changes was created and sent to a central, if there was any conflict in those set of changes anywhere, for example, two people changing the same tag or two people changing the same graphical element, then it would immediately recognize there was a conflict, and it would just discard the entire set of changes that one of the contributors created. So if you didn't synchronize your changes because you were offline for a couple of days and you went to synchronize with a system, or synchronize with the central system, all of a sudden you would see none of your changes, or you would see none of their changes that had occurred during that period. So we ended up having to change the version control design within the VTScada system, redesigned to handle conflicts by accepting all but the conflicting changes, and therefore discarding only a very minor number of conflicts, usually 0, but every now and then 1 or so, and allowing selection of the preferred source when there was a conflict. We also have out-of-network change synchronization. So a lot of words there for essentially describing the out-of-network connected user, which is the Embro engineering in this case. Not all partners were given online access to synchronize with the main configuration server. So their changes had to be delivered to an in-network partner who would then automatically synchronize and provide the updated information, which we call a change set, back out to the out-of-network user. So those problems were solved. And then we ran into some PLC changes. And this is one, I don't really want to get into this too much, but essentially in order to see all the data, it became easier to look at that data in the centralized cloud configuration using a thin client server. It's a potential solution, has not been applied yet because there wasn't really a need to, but we got past it. The centralized servers, this last one, cannot poll the local PLCs because they did not want the central network to be connected to people's local networks and have the ability for the central network to dig straight down into the local network at someone's house. Because we ran into COVID, everyone was working from home. They also did not want Jacob's network to be inside CDM's network. So what we had to do was to, all of these people had the PLCs locally at their own houses they were working with, or at their offices if they weren't, if they didn't have to stay home because of COVID. And we had to devise a methodology by which the users could temporarily reassign a PLC to say their local workstation was the server for that PLC, and then contribute its data up to the centralized cloud, while also doing the synchronization of changes and everything else. Worked great. Had never done it before, but now a methodology that we're utilizing for a number of different facilities. So today and tomorrow, how are we, where are we now, where are we going, and what are we going to do with all this cool new stuff we've figured out? Well, these are some of the standards that came out of that. And it was very easy utilizing this methodology to both deploy these standards. This is all standard out of the box product features. So they fit the mold very well. You'll notice that while this is intended to be an ISA 101 application, there are bits of, we'll call them leftover graphical elements from a different time, where the methodologies of, say, showing something running in green is still utilized. And that is utilized because that was an operational decision made as a preference by the end user client. So they went almost 101, which is what I was talking about in the beginning of the presentation. But once these standards were created and added to the project, then they could easily be utilized everywhere. We also have the ability to change the symbols as need be, and those symbol changes are automatically reflected in every one of the graphical elements, the screens and such that have been developed to date. Here's an example of a level 1 display. You see there are quite a number of different parts on the top, different subsections of the system that you can go to from here. It's well laid out, and it's really just the beginning. We've got hundreds of screens created so far. There will be probably hundreds more by the time this is said and done. And we're trying to utilize as much as we can the process flow combined with the high performance type graphical elements. Again, standard stuff in the product. So we tried to not have to create anything that was unique to this product other than some complex templates of standard simple widgets. We've templated everything. All pop-ups and instrument displays have been templated by the CDM team, actually by all 3 teams. And these are then shipped out, synchronized to all users in real time. So when they develop a screen, they get exactly what the representation is in the real time. And we've done one round, or they've done one round, I should say, so far, of alarms rationalization, which could be done because all of the alarms were contributed by all the teams at the same time, over this period, I should say. And we're now working for additional tools to enhance the alarms rationalization process on an ongoing basis, and as this process rolls out over the next several years. Some additional pieces that really came into benefit here, the ability to utilize nuisance alarm detection and flood management. So we quickly could find out if there was anything here of concern just with the design out of the box and the testing. And then once things go into the real-time runtime environment, operationally, we'll have all these tools ready for us and they'll go into place immediately. So we have a two-phased deployment, as I mentioned, one train, and then the other is essentially a duplication of the first train. We have train number one, 2020-21 deployment. Development has been ongoing since late 2018 and early 2019. These standards have been maintained, which is good. It's exactly where we wanted to go. We've got reassigning the PLC server lists as equipment is delivered to the site. So we're able to do that without having to restart the computers or restart the application in any way. We just reassign the equipment server list and boom, there it is, it's live and comms drop over to the new server instead. We're going to use a progressive deployment methodology. And that methodology is intended to allow progressive commissioning, development of new features, and deploying them without creating any downtime within the system. This is phase two. So phase two is an interesting expansion of phase one. We're going to use the synchronization methodology again, and we will have phase one utilized as a base layer. So you see it there in the center with the arrow going through it. The expectation is that phase one, we have all its templates and its standards and such, and its graphics and elements, alarms and such. And we will continue to modify that over time. So we could not take phase one as a base that would not then be modified and create phase two based on it. We had to allow phase two to continue to accept new templates, new modifications from phase one. So this is the methodology we're going to follow. Phase two will continue to see whatever version of phase one is currently available, because we will sync them as those changes are made. And then eventually we will migrate phase two down into phase one and deploy those elements of the process out. So we'll have a complete project in the end that will include both phase one and phase two. So I think just click on that, one last one. So leveraging the platform, we've done all this really neat stuff. We've made the system work well. It's able to be utilized for growth, and we're going to reutilize, I should say, Jacobs is going to reutilize the methodology that they've created in the cloud-based configuration environment, and they are now utilizing it again for Fayetteville, Arkansas, which is underway right now, with different users in different offices again. They're utilizing it for Montgomery, Alabama, when that goes ahead, and there's other projects in the works as well. The primary benefits of this methodology is that it supports the multiple projects simultaneously. You can have as many projects being developed at the same time as you like, as long as the resources of your server are capable of handling the additional load from all of these additional projects. So with a virtualized environment, that becomes quite easy. You just add in the additional resources, or you upgrade the server to handle the speeds that it needs in order to computate the computational power that it requires. It also supports future expected working conditions, which currently we've been going through for the last 8 months, had a lot of success with this methodology. So I think we're pretty hardened to it. We've got the multiple office configuration projects, which was our initial idea, and then translated to a work at home methodology. And we had to make a couple of adjustments there, but it's worked out. And finally, the hardware at the developer's location, rather than all centralized and accessible via the central server. We've got new methodology coming out with thin client, or actually it's out, with thin client development tools, which will also minimize having the need for dedicated developer licenses that will then be distributed out. Typically, right now, I believe the understanding or the methodology is typically you would distribute out developer licenses via virtual PCs with that loaded on it. And then you would check them back in. So you're back to this check-in, check-out methodology. This process here allows you to utilize thin clients themselves for the development environment. Thus, you don't need anything installed on your machine whatsoever. And you can have as many developers working at the same time. So the goals we've reached are essentially, this is the same slide that I showed in the beginning. We are working very effectively and very efficiently. We have minimized errors greatly. We had some errors that we had to work through. Not everything was seamless. So in working through these processes, we came up with some speed bumps. We were able to get over them. And finally, we've reduced the risk because now we have a distributed system where everyone knows, everyone has a copy of their the configuration. That allows us to work in this shared environment, either online or offline. And we've been able to identify a number of problems early by testing with real PLCs on a live system. So that gives you some, no, I shouldn't say live system, on an online system. And that's what I have to cover there. So thank you, Colin. If there's any questions, I'd be happy to answer them.
Thank you, Blair. Let me see. We have one that says, thank you, Blair, for this interesting webinar. I feel this project has lots of similarities with the ITER project being built in south of France. In terms of complexity and diversity, I am sure that a specific control system design, quote unquote, Bible was created for this project. Can you please elaborate on that? Thank you.
I wouldn't say a Bible was created on that, but I would definitely say there's been a lot of things learned. And I think what you're looking at right now is probably the accumulation of the learned concepts in this. That combined with the standards document and a few other, obviously, critical pieces. I would like to be able to share more of this information, but I will have to get verification from the main partners and obviously the City of Houston to share more details beyond this. It's about as far as I can talk about it at the moment.
It's Patrick Cook from Trihedral, if I may for a second.
You might.
One of the other things which is, Blair hasn't touched on because it's not really a part of this presentation, but we, in version 12, have an interesting capability where all the text phrases in standard VTScada have been isolated. And so the text strings are isolated. There's a column of the English words that appear in those text strings. But there's also additional columns where you can put in different text strings from different languages. And we support UTF-8 and UTF-16. Long story. So we now in version 12 have this ability within the same application to readily change languages on the fly. So it's not affecting the program itself. It's just the graphical interface can go to essentially any language that you elect to support. So we're in the process of finalizing the new control system for the St. Lawrence Seaway Authority. So all traffic, obviously, from the Great Lakes out to the ocean will be going down the St. Lawrence Seaway. And that program can switch from English to French on the fly. So if the operator's looking at the screens and they're in français, and his supervisor, for example, puts his head over his shoulder and says, I'd like to see that in English, all you do is you click a button and the entire program goes to English. And so that capability is available in essentially any language that you would like to implement support for that particular language. So if you mention something in the south of France, for example, very easy to have the development work occur in North America in English, and then have that program available in the south of France to, again, seamlessly switch between English and French.
Yeah, I forgot about that, Pat. Thank you. What other questions do we have, Colin?
Thank you for that, Pat. Right now, I'm not seeing any other.
Okay.
Let me see what time we got. We got 10:51. Give it a minute if you would like. See if any roll in. We still have some people on the line here.
Blair, just a quick question. Any idea of how many IO will ultimately be involved in this project?
IO, I don't exactly know. Right now, the projection is about 160,000 tags. And I'm hearing tens of thousands of IO, so I don't know exactly how many that would be, but I'm sure it's way up there. And we don't even know where that's going to escalate to. You know how these things go. You start in one place and you end up with a factor of growth of 10%.
But I mean, it's significantly below some of the 1.5 to 2 million tag systems we have running currently elsewhere.
Yeah, yeah.
All right, looks like we got another one. Are you working on developing new ways of conducting control system FAT and SAT in this new normal scenario in post-COVID world?
Well, the FAT and SAT are essentially being done on the system in real time. So they will be essentially duplicated. They could be done at home with the system. And then, so we've just done it actually. I was down last week working with the Houston team. We had a PLC that was completely fatted out offline, and then it will be brought to the system and duplicating that procedure again inside the new NEWPP development area. So we've now got an assigned area that has all of the PLCs in it. We're moving them into that area. But essentially, it's just a duplication of work. We can do a lot online in real time without having to be on site now, which we were relatively unable to do before. And we'll just bring each PLC online in the FAT test. So I think it would be an easy methodology if you wanted to look at expanding it to include any number of PLCs or any number of remote offices developing any number of PLC programs.
Thank you for that, Blair. I am not seeing any more questions here.
Okay.
So on behalf of CSIA, I would like to thank Blair for this informative discussion and all of those attending. A link will be sent to you. I believe it is to be sent out a day after this webinar, and it will provide a link to the recording of this webinar. And be sure to check the CSIA online events calendar for all upcoming webinars that you may be interested in. And with that, that concludes our session today. Thank you, gentlemen.
Thank you, Colin. I greatly appreciate it.